In today's lesson, we're going to look at solving problems using the Pythagorean theorem. And so when you're solving a word problem, what you need to do is you need to create a diagram that represents the problem. And on your diagram, you need to label it appropriately. Things you know and things you don't know. So the things you know you put on, the things that you're trying to find, you use a label. And so what we're going to do is we're going to read through the problem once entirely, try to get the gist of the problem, then we're going to go back and piece it together and try to create the word problem, or the diagram. A ship leaves the Pacific coast of BC and travels west for 10 kilometers. Then it turns and travels north. If the boat is 25 kilometers from its starting point, what distance did it travel north? Give your answer to the nearest tenth of a kilometer. So we go back and we say, okay, we have this ship, so we have to create a starting point. This is where we start. Then it travels west. Using our diagram of north, east, south, west, we can see that west is to the left. So we're going to go 10 kilometers, and we're going to put that on our diagram, and we travel 10 kilometers to the west. Then from its new position, it's going to travel north. We have no idea how far, so I'll put an X there because I don't know how far it's traveling, but it is traveling in the north direction. We know that our directions create 90-degree angles. Okay, so when we see a 90-degree angle, let's put it in our diagram because that'll help us look for right triangles. We do know the boat, where it is now, from its starting position, so all the way down here from its starting position, is 25 kilometers away. So let's put that in our diagram. So the now to the starting position, that distance, so in other words, if it had to turn and head back to where it started, it would have to travel 25 kilometers. So now we have a diagram in which we know two sides of a right triangle, and we're missing the third. So now that you have your diagram, you can go ahead and use your Pythagorean theorem. So I pick the formula I want. I know that b squared equals c squared minus a squared. I use my substitution. X squared equals 25 squared minus 10 squared. I go to my calculator and I type in 25 squared minus 10 squared, and I write the answer below it. This is the algebraic way of writing it, right? So since I know x squared is 525, I know that x is the square root of 525. And again, I go to my calculator and I type that in, and now before I write my decimal, I check back in the question to the nearest tenth. Tenth is 1 decimal place. On my calculator, I see 22.9128 ... If I want it to the nearest tenth, I look to the one beside it. It's a 1, so that 9 stays as is. So it traveled north for approximately 22.9 kilometers. Let's try another one. This one's a little trickier. Two telephone poles are 60 meters apart. The poles are 42 meters and 60 meters high. What is the distance between the top of these two poles? So I kind of supplied the diagram already, but now we have to fill it in and decide what different distances are and what we're trying to find. So we know the shorter pole is 42 meters. We know the taller pole is 60 meters, and we know that they are 60 meters apart. What are we trying to find? We are trying to find the distance between the tops of these two. So the top here to the top here is the distance we are trying to find. So let's put an X there. So that's not a right triangle. So I need to figure out how can I create a right triangle that includes that red line. So what I could do is I could extend a line across here, parallel. See how those are parallel? Parallel to the ground. And you see now I have this right triangle. Now I have a right triangle. Do I have enough information in that right triangle? Let's see. Well, do I know this distance? Well, if I know the whole height is 42, or sorry, the whole height of this pole is 60, and I know this height is 42, right? Because I drew a line parallel to the same height, then I can just go 60 minus 42, and I can get 18. So I now know the height of that triangle. Do I know the distance between the top of the shorter one straight across? Well, yes, it's the same as the bottom, right? Because those lines are parallel. So I can transfer that 60 up there. So now I have enough information 60, 18x to find the distance between the tops. I found a right triangle within my diagram. So I can say, well, the x is the hypotenuse, so c squared equals a squared plus b squared. Or in other words, x squared equals 18 squared plus 60 squared. Go to my calculator and type in 18 squared plus 60 squared. And I get x squared equals 3,924. Or in other words, x is the square root of 3,924. And I get, does it say, it doesn't tell me where to round off, so I get this on my calculator, etc. I can choose where to round off. I could write it as 63. I could write it as 62.6. I could write it as 62.64, 62.642. Whatever you choose to round off to, you just have to round off accurately. I'm going to round off to the nearest tenth, or 1 decimal place. So I know the distance between the two tops. So if I had to create a wire to connect from the top of this pole to the top of that pole, I now know how much wire I need to make that distance work. All right, let's find these unknown lengths. So here I have a box. And the first length I want to find is I want to find the diagonal on the bottom of that box. It's kind of tricky to see because I have a 3D picture on a 2D space. But if you looked at the bottom of the box and we tilted it towards us, so if I just drew the bottom of the box and I tilted it towards us like a bird's eye view looking straight down at the bottom of the box, it would be 9 by 12, and that diagonal B would be right there. So everybody could see that we actually have a right angle right there, right? And we can see that our right triangle matches up. So I can find that diagonal B on the ground, right? By using my Pythagorean theorem. I know this is 9 by 12. So B squared equals 9 squared plus 12 squared, or in other words, B squared equals 225, or B is the square root of 225, which is 15. So I now know B is 15. Now what I'm going to do is I'm going to use that information and does everybody see this standing upright triangle, right? Where there's a 90-degree angle there. So it's a vertical triangle in which they share the same side. B is the hypotenuse of that triangle on the base, but it's the leg of that triangle standing up, right? Where this distance here in my triangle is 8, this distance here is 15, and I want to find D. So now I know that, oh, D squared equals 8 squared plus 15 squared. 15, right? So I had to use that information in that triangle. So I take my 8 squared plus 15 squared, and I get 289. Let's change colors, but that's okay. And then I take the square root of that, and I get, oh, D equals 17. So I can find, I call that D the space diagonal, right? It's the space diagonal of that box because it goes from the front bottom corner to the back top corner. So it's a diagonal of a 3D object, which I call my space diagonal. So you need to first find that and then find this. There's a shortcut, so I'm not going to show it to you, but if you can maybe take the same question, but instead of using numbers, you use letters. Let's call it X, let's call it Y, and let's call it Z. And then first find this diagonal using your X and Y, and then find the space diagonal using the answer to that, and see if you can come up with a formula for finding the space diagonal. Give that a try. Come see me if you want to check your answer.